Okay, to make a graph of the derivative, you're going to need some points. So I'm going to use my function to get those points. And the easiest points to get are where the derivative goes to 0. And you will always notice that to be at the vertex or vertice on the graph. So I started with the ones you see in black where it says m equals 0. I drew the tangents. At those 3 different points, my derivative will go to 0 because the slope of the tangent line goes to 0. So those are the first 3 important points that we're going to talk about. One, oops, let me change my pen to black. Matches color coded. Number 1, at point 1, the second point has an x value of about 3, and the third one is about 6. Now, another thing you need to understand is I'm just estimating. That means you cannot find exact answers. If you have exact answers, you probably didn't estimate. So whatever I get here, it doesn't have to be exactly 1. Maybe the very first point is really at about 0.75. Could be. So, but that's okay. It's an estimate. So that's really important. Your graph can be slightly different values. You can have slightly different answers and come up with the exact, correct, acceptable answer and get full credit here. So, what do I know about this? Very first point, when x is 1, the slope of the tangent is 1. That's my derivative. When x is about 3, the slope of my tangent, again, is 0. And at x equals 6, the slope of my tangent is 0. First 3 points, very important. Now I'm going to erase those so I don't have to look at them. And talk about these other points I've chosen. So I'd like to talk about these 2 points here. I chose these 2 points here because they are approximately the steepest the graph goes in between where it was 0, because the derivative is 0 here, the derivative is 0 here. This red point here appears to be where the graph is going down approximately the steepest. And again, it's just an approximation. And this green point here appears to be where it's going up the fastest. So I'm going to get now tangents for these points. I'm going to start from left to right, and I'm going to do my green points next because they're going up. And I'm going to draw a tangent line. And what's probably going to bother you about this tangent line is there are no y values, so I can't come up with a value for it. All I know is it is bigger than 0 because it's positive. That's a positive number. Now, it might seem to you that it's going to be kind of hard to make an accurate graph without having a positive number, so let's just make one up temporarily. And again, it's just a make-up because it doesn't matter. And this is really important. So choose a positive number. I'm going to choose the positive number 2. Why? Because I felt like it. Now I'm going to go to the next positive point here and draw its tangent line. And again, this slope is bigger than 0. Looks about the same as the other one. I'm going to call it 2 as well. Why not? Again, this is very important that the exact value, steepness of the derivative doesn't matter. Only whether it's positive or negative. And that's the key aspect you need to understand. Only if it's positive or negative matters. So look at my negative ones. Oops, let me go ahead and erase what I did here and bring back this negative point. Okay, my slope of this tangent is not positive, it is negative. Looks a little bit less than the 2, so I'm going to call it -1. Why not? I go to 8. Ooh, this one's much more negative. It's much smaller than 0. So at 8, maybe that's a -3 slope. It's all good. Why? Because when I plot these points on a graph, I'll be able to answer the question. I'm not going to scale my y because it doesn't matter. So I need to go, let's go from, let's see, actually this graph was more like this. -2 all the way to 8, right? 2, 3, oh, -1. Actually, I'm going to go up by 2's. So, -2, +2, 4, 6, and this is 8. I'm not going to have any y values because it doesn't really matter. First point, -1, that's about here, and then +2. It doesn't matter how high you put it. So I'm just going to put it here. Why not? Next point, 1, that's here, 0. Next point, 2, -1. So 2, -1 is less than 2. We'll put it about here. 3, 0. 3, 0. That's here. Next point, 5, 2. Let's see, that's 3, 4, 5, 2 is about here. And then we have what, 6, 0 in black. And then 8, -3 in red. And I'm going to connect the dots with a smooth curve. As smooth as I can draw. Again, it doesn't have to be pretty. It doesn't have to be pretty at all. Just want it smooth. Okay. So we want to know when the derivative is what? Increasing? When the derivative is decreasing? Is that the question? Let's go back. Increasing and decreasing. So now let's look at my graph. Increasing means to be going up. Decreasing is going down. I'm going to circle everything that's decreasing in red. It's decreasing here and here. So from approximately -infinity until we reach 2, it's going down. And about, again, these are estimates, around 5 to +infinity, it's going down. It's going up, I will circle in green, in the middle. From about x equals 2 to about x equals 5. Hopefully this makes sense and gives you a little insight on how to create a derivative from a graph.